So now we're going to go ahead and do this very same problem using the slightly modified slide and scale method. So remember, the first one is scale and slide. This is slide and scale. One of the differences is that in this second method, the first thing we do is we slide or horizontally translate the graph along the x-axis, and then after that we scale it. That requires that we use a slightly different scaling factor. So if we go ahead and write out our function again, it's negative cosine. Again, I'm ignoring amplitude and vertical shift for the moment because we can handle that in the drawing portion. We've got negative cosine 2x plus 3/4 pi, and again, this is our scaling factor. It's still 2, but our sliding factor, because we're doing the slide first, is going to be 3 pi over 4. Unlike the other method where we factored, if you do your slide first, you don't factor. You're actually going to slide by 3 pi over 4 and then scale by 2, or by 1/2 actually. You're going to be dividing by the coefficient of x. So let's go ahead and let's do this. So once again, we start with our parent function, which is negative cosine of x, and we have to know how to draw that out properly. And just like we did before, we draw out our curve, and we have the same landmarks in terms of x values. Okay, so we start with the very same curve, but the first thing we do is slide. So because this is a plus, we're going to slide to the left again. So that does not change. So we're going to go ahead and now we're going to slide this curve to the left by 3/4 pi. So we've got to subtract 3/4 from each one of these values and then redraw the curve where those values fall. So 0 obviously becomes negative 3 pi over 4. And this may not be to scale. Okay. Pi over 2 minus 3/4 pi is going to be negative pi over 4. Pi divided by minus 3 pi over 4 is simply pi over 4. 3 pi over 2 minus 3 pi over 4 is going to be 3 pi over 4. And then 2 pi minus 3 pi over 4 is going to be 5 pi over 4. Okay, so these are the new positions of our 5 important points, but we know we still have the same curve. We're just sliding it down. So our minimum occurs here at minus 3 pi over 4. Our 0 value at minus pi over 4. Our maximum value at pi over 4. And then we come back down to hit 0 again at 3 pi over 4 and come to our minimum at 5 pi over 4. Okay, again, artwork that will not be missed. But nevertheless, that is the idea. We go from minimum to 0 to maximum, back to 0 and to minimum again, and we've done our slide correctly. The next thing we do, secondly, is to scale. We use the same scale factor, so we are going to be dividing through by the x-coordinate, which is 2. So let's go ahead and do that. And let's just divide every one of these values by 2. So negative 3 pi over 4 divided by 2 is negative 3 pi over 8. Negative pi over 4 divided by 2 is negative pi over 8. And, you know, just really not to scale, but let's just keep going. Pi over 4 divided by 2 is pi over 8. 3 pi divided by 4 over 2 is 3 pi over 8. And 5 pi over 4 divided by 2 is 5 pi over 8. If we go ahead, and of course this should have been done to scale, and it just wasn't, but let's go ahead and redraw it. So we've got 0 there, negative there, we've got 0 there. We hit our maximum pi over 8, we come back down to 0 at 3 pi over 8, and we hit our minimum at 5 pi over 8. Well, take a look side by side at what we've got through both methods, and you'll see we have reconstructed the exact same graph. Okay, in both cases, we're starting at a minimum of negative 3 pi over 8, hitting 0 at minus pi over 8, hitting our maximum at pi over 8, then coming back down, hitting 0 at 3 pi over 8, and then hitting a minimum at 5 pi over 8. It's the same in both graphs. So it does not matter which method you use. You could do scale, slide, or do slide, scale, but you just have to remember that the main difference is the factor for the slide. Okay, so you factor out the coefficient of x if you're going to do scale and slide, and you do not factor it out if you're going to do slide and scale. Well, I hope that this short video has been helpful.